Hi guys, so today we're going to go over eliminating the parameter with trig functions. I did note the steps in the previous video, so make sure to go over those and list the steps down because we're just going to apply it today here in this video. So the first step that we're going to do is just to isolate the trig functions. So we want cosine and sine by itself. So I'm going to take x equals -2 cosine of theta. And I'm going to divide -2 on both sides to isolate that trig function of cosine theta. And then taking the second equation, y equals 3 sine of theta, I'm also going to eliminate that 3 so that I can isolate the trig function of sine theta. So dividing both sides by 3, y over 3 equals sine of theta. And then we always look at our Pythagorean identity next because that's what cosine and sine have in common. So sine squared plus cosine squared equals to 1. And we're going to replace the sine value with y over 3 and bring down that it's squared following this identity. Plus, we're going to replace cosine with its value -x over 2 and also square it equals 1. So we're going to square each fraction, which I would square each one individually. So the numerator y would be squared, the denominator 3 would be squared. Keep in mind the second fraction, when you square a negative, it will be positive. So it will be x squared over 2 squared equals 1. This is the equation of an ellipse, where the center, there's nothing being subtracted or added to x and y, so the center would be 0, 0. And in an ellipse, remember A is always the larger value representing the major axis. So in this case, A would be 3 and B would be 2. So I'm going to graph the center, 0, 0. Again, noting A is 3 and B is 2. What this tells me is that the distance from the center to each vertex would be 3, and it's vertical because the 3 is under the y. And the co-vertices are 2 from the center from the left and the right. 2 from the left and the right because the 2 is under the x. So once I have my vertices and my co-vertices, I can just graph my ellipse. So we have the sketch, but we have to note its orientation. Now, since we're dealing with a trig function, we know that the unit circle goes counterclockwise. So the angle 0 is where we begin. And I'm just going to use the quadrantals. So 0, pi over 2, pi, you can use them in degrees or radians to determine the orientation. I'm just using radians. And I'm going to substitute the values into the given x and y equations. So for instance, theta 0, I'm going to write x equals -2 times cosine of 0. Unit circle, cosine of 0 is 1. 1 times -2 is -2. For the y value, I'm going to replace theta as well with 0. 3 times sine of 0 is 0. 0 times 3 is 0. So I know that this is the first point, which is at -2, 0. So that's where we're starting. And then to see where the next point follows so I can find its orientation, I replace the thetas with pi over 2. Cosine of pi over 2 is 0. So 0 times anything is 0. And 3 times sine of pi over 2, the sine of pi over 2 is 1. 1 times 3 is 3, so I know that 0, 3 is my next point. So that is the orientation. And then you can follow up from there with pi to find where it goes. But once you know if it goes clockwise or counterclockwise when it's an ellipse or a circle, kind of know its orientation from there. All right, hope this helps.